Hello, everybody. This is chapter 3.5. We've got three more lessons in this chapter 3 where we're introducing ourselves to graphing linear equations and introducing ourselves to linear equations in general. So that is what we're doing today. We are going to be graphing using slope-intercept form. This thing right here called slope-intercept form. It is a specific type of linear equation. We have one type that we've already talked about, and that is standard form. And remember, standard form was ax plus by equals c. So when I'm taking an x term and a y term, adding them together or subtracting them together, and getting some other constant, right? A, B, and C have no specific meaning in standard form. Have no meaning, right? They're just numbers. They're just numbers that they don't, nothing specific. Today, the form that we have will have specific numbers that are specific meanings, right? They'll have things that represent the slope and the y-intercept. And over the course of the past couple of days, we've talked about what slope is, we've talked about what the y-intercept is, and the x-intercept. And now we're going to sort of combine these two terms to be able to graph an equation without having to make a table. Okay, so we're learning a more efficient method today, more efficient method of graphing. So something to make it a little bit faster for us rather than doing a lot of calculations. Okay, so let's move on. A linear equation of the form y equals mx plus b is written in slope-intercept form, where m is the slope and b is the y-intercept. So m, that guy right there, is the slope, and the b, that guy right there, is the y-intercept. Whatever numbers we have in for those particular values represent the slope and the y-intercept. So whatever number is in for this m right here, that is going to be what the slope is, and whatever number we have for the y-intercept there, that's what the y-intercept is. So to give you just sort of a quick example of that, when we have something that is y equals mx plus b, okay, and then we have an equation like y equals 1/3 x plus 2, okay, this number right here is the slope, right? The slope is 1/3. And this number right here is the y-intercept, which is 2. Okay? Notice that the m in this case, the m is 1/3. Therefore, it is the slope. And the y-intercept is 2. And remember, of course, slope from what we were talking about yesterday and the day before that is the rise over the run. Right? That's the definition of the slope. This means we're going up 1 and right 3. Okay? And we can graph that. If we have those two values, we can use them to graph the equation, and we can do that without making a table. Because remember, the y-intercept of 2 gives us a point on the y-axis, right there. And the slope is the rise over the run, meaning I'm going to go up 1, and I'm going to go right 3, because that's a positive 1 and a positive 3. So on the y, I'm going to go up 1, and on the x, I'm going to go right 3. So I'm starting here, and I'm going up 1, and I'm going right 3. And I know that there's another point right there. And I know that if I go up 1, right 3 again, there's going to be another point right there. They're all going to have the same steepness, the same increase of 1/3. What do you want? I'm recording right now. You're interrupting. Here, I'll pause. Okay, sorry, that we're back. Had a senior coming in. What do you want now? Oh, okay, that's fine. Sorry, now I'm yelling at freshmen. So I'm trying to record your lesson for today, Michael Perusik. Now second period's gonna be like looking at you. The moment they watch this, 6 minutes into the video, look at the class and they're all gonna look at you. Thank you. Okay, so anyway, that's how you graph. Okay, the y-intercept of 2 gives you a point. The slope is the rise over the run. So we're gonna start at that point and then use the slope 1 up 1 right 3, and that's gonna give us our points. That's gonna be the line that we create. Okay. Let's do a couple of examples here. So identifying slope and y-intercept. I want you to do that today. I'm simply going to give you. Whoa, what just happened? I need a pen. Got to be a pen there. You're going to have a couple problems today that, just as some initial practice, can you identify what the slope and the y-intercept is? Something like this, fairly simple, right? It's whatever is multiplying the x is your slope, so that's 3, and whatever is beyond that is 4. Man, I'm getting all the interruptions in the world today. I'm recording. What do you want? What? All right, we're gonna try this one more time. We're gonna get through this without interruptions. Eventually. Okay. So what happened? I lost my thing. Y equals 3x plus 4. My slope was 3. That's not a 3. And then my y-intercept is this thing over here that is being added onto the side. Now, we can write the equation like this, and note that my slope is still 2, and my y-intercept is still 3. It's the number multiplying the x that makes the slope. It's the number being added or subtracted on that makes the y-intercept. Now, you may even have to do a little bit of work first, like in a problem like this. Notice that this is not in slope-intercept form. Slope-intercept form needs to be y equals. And this is not y equals right now. So in order to identify slope and y-intercept on this one, you got to do a little bit of work first. We're going to have to solve for y. And when we solve for y, we end up with something here that we can then identify the slope as -3 and the y-intercept as 2. Now, let's use that information to actually graph something. So let's create a graph, and I'm just making some rough sketches here, but we'll have good graphs for you. And I just want to graph something that has a slope of where's my thing? A slope of -2 and a y-intercept of 5. And so I'm going to start where my y-intercept is, because this is a point on the line, and that is at +5. Y-intercept crosses the y-axis at 5. That tells me to start. We sometimes call this the initial value, because it's sort of the first value we use. From there, I'm going to use my slope, recognizing that this slope is -2/1. So my rise is -2 and my run is 1. That tells me to go down 2, right? Because it's a -2, we're going to go down 2, and then we're going to go right 1. So starting here, I'm going down 2, right 1, right? There's my down 2, and there's my right 1. And I'm going to do it again. And I'm going to do it again. Going down 2, right 1. And that's my graph. I don't have to do anything else. I don't have to make a table, right? If we have this pattern of y-intercept and slope, we cross at 5, we go down 2, right 1, down 2, right 1. I have everything that I need. We can do the same thing if we're looking at it straight as a equation. Here my slope is 5, and my y-intercept is -3. Notice that I carry that sign with it, that operation with it. Use that information to graph the linear equation. Start at my y-intercept. That's -3. Broke my pen again. And that's -3 right there. Use my slope of 5/1, rise over run, telling me to go up 5, right 1. So we're going to go up 5 from here, up 5, 1, 2, 3, 4, 5, right 1. That's where I have another point. Recognize that if I would plug in 1 into this equation up there, I'm going to get 2 as a solution, right? 1, 2. I know that that's a point on the line. If I plugged in 1, I would get 2. 5 times 1 is 5 minus 3 is 2. See how that works? We can avoid the step of creating the table by understanding this pattern between y-intercept and slope. All right, that's everything that I've got for you today. I have a couple of sample questions for you guys to do, so come grab those from me, and then once you're done with that, you can check those with me, and then you have your assignment to do today. So good luck.